The Turkish defense industry has developed rapidly over the past 2 decades. One symbol of this transformation is the presence of modern attack helicopters designed and manufactured domestically. Behind their aggressive performance and advanced technology lies a long and complex assembly line process that combines precision engineering, weapons system integration, and rigorous pre-flight testing. The heart of Turkish aerospace production, the Turkish attack helicopter assembly line, is centered at the Turkish Aerospace Industries TAI facility in Ankara. This industrial complex is more than just a large hangar, but rather a high-tech manufacturing ecosystem encompassing composite structure production, avionics integration, weapon systems, and ground and air testing. The journey of an attack helicopter begins with sheets of composite material and high-precision metal blocks. The fuselage is constructed using a combination of lightweight yet strong composite materials, aerospace, aluminum alloys, and titanium components in high-load areas. The fuselage panels are manufactured separately and then assembled using precision jigs to ensure perfect structural alignment. In aerospace, aero tolerances can be millimeter or even micron-leveled. CNC computer numerical control technology plays a crucial role in the production of mechanical components such as engine mounts, transmission systems, and rotor elements. Each component undergoes non-destructive inspection, using ultrasonic or radiographic methods to ensure there are no internal defects. Once the main structure is complete, the helicopter enters the mechanical systems integration phase. The turbine engine is installed along with the main transmission system that will drive the rotors. On platforms like the T-1298A, the drive system is designed to provide a combination of speed, agility, and weapon carrying capacity. Engine installation involves more than just physical installation, it also involves calibration. The main rotor is installed with extra care, as it is a vital component for stability and lift. Each rotor blade is balance tested to prevent excessive vibration during operation. At this stage, the helicopter begins to come to life electronically. Complex cables are embedded throughout the aircraft's fuselage, connecting sensors, mission computers, radars, navigation systems, and cockpit control panels. Modern attack helicopters utilize the glass cockpit concept, a multifunctional digital panel that replaces traditional analog instruments. An electro-optical targeting system is mounted in the nose section, enabling day and night target detection. This integration requires complex software synchronization. Each software update must undergo rigorous simulation and testing to ensure there are no system conflicts. The primary identity of an attack helicopter lies in its weapon systems. On the assembly line, stub wings are fitted with mountings for anti-tank missiles, guided or unguided rockets, machine guns, or automatic cannons under the nose. Weapons integration involves more than just attaching the launchers. It also connects them to the fire control system and mission computer. Each weapon must be able to lock onto targets accurately, receive ballistic data, communicate with sensor systems, and this process involves simulated firing tests before the helicopter is actually tested on the firing range. Before being declared operationally ready, each unit undergoes a series of tests. Ground run test. The engine is started while the helicopter is still tied to the ground to test the performance of the engine, transmission, and control response. Vibration test. Sensors are installed to detect abnormal vibrations that could affect the structure's lifespan. Hover test. The helicopter is tested hovering several meters off the ground to check the stability and response of the flight. Control system. Test pilots perform extreme maneuvers, including steep climbs and simulated combat scenarios. Every flight data is recorded and analyzed by a team of engineers. If anomalies are found, the unit is returned to the hangar for adjustment. Turkish attack helicopter assembly lines adhere to international military standards and multi-layered quality control procedures. Each part has traceability documentation. This means that if a component experiences a problem in the field, the team can trace its production back to the batch of material. This approach reflects Turkey's ambition to achieve self-sufficiency in the defense industry. By producing its own attack helicopters, the country reduces its dependence on imports and strengthens its geopolitical position. The successful production of the T-129 attack paves the way for the development of the next generation, including heavier and more advanced attack helicopter projects. Ankara's assembly lines are constantly being upgraded with automation, robotics, and digital manufacturing technologies. This transformation demonstrates that assembly lines are not simply places to assemble war machines, but centers of national innovation. Inside the vast hangars, engineers, technicians, and test pilots work in high-precision synchronization, transforming thousands of components into a single, complex air combat system. Inside Turkey's attack helicopter assembly lines, every bolt, cable, and panel tells a story of technology, engineering, discipline, and strategic vision. From the fabrication of composite structures to the final flight test, the process reflects the rigorous standards of the modern aerospace industry. Turkiye develops and manufactures a variety of aerospace platforms, but its attack helicopter line is among its most strategic. This is where platforms like the T-129-8 VAK, used by the Turkish Armed Forces and exported to several countries, were born. The helicopters that finally take to the skies are not only symbols of military might, but also represent the industrial progress and technological ambition of a country seeking to stand alongside global aerospace manufacturers